All right, chapter 9, rational expressions, continuing with number 9. So here the directions say to simplify the expression, and it doesn't say to list the excluded values, so I'm not going to. So we've got two different fractions here, right? Or we could think about it as two different numbers here. This is like 3 over 1, right? And we want to combine those to be a single fraction, okay? Now, if we had two fractions like, I don't know, 3 halves plus 2/3, we would get common denominators of 6, right? We'd turn this into a 6 and that into a 6, right? We're going to be doing the same process. It's just a little bit different because we have variables. What I like to do first, very first on here, is I'm going to factor everything as much as I can. So let's do that. The right side here is the only piece that's really going to factor. So I'll have, and I'm going to write it as 3 over 1 plus 2b over, I have 6b squared, so I can take out a b squared, or I can take out a b, and I think I can take out a 6, right? Yeah, this will be 6b, and this will be 1 minus, this should be a b there, 6b, and then b minus, what is that? Is that 4? Yeah. All right, so now you might be seeing why I wanted to factor it first. We can cancel these b's out, and we can also cancel the 2 and the 6 out. The 2 and the 6 cancels to be a 3 on the bottom, right? If we have the fraction 2/6, that's 1/3. So I'm going to rewrite this as 3 over 1 plus, our numerator now in the second one is just a plain old 1, and then we have 3b minus 4. All right, now we've factored, we've canceled. Now we need to put them together. So the left side here needs a common denominator. So we need to multiply this by 3b minus 4, and 3b minus 4, right? That's what I need to do to get the denominator on the left to be the same. So this will turn into, well, I'm going to put this 3 and this other 3 together to be a 9b minus 4 over 3b minus 4 plus, and the right one is 1 over 3 times b minus 4. My denominators are now the exact same thing, so I can put these together. Now I'll have 9, actually, you know what, I'm going to distribute this out. I'll have 9b minus 36 plus 1 over 3b minus 4. And then combining like terms in the numerator there, I can say, well, 9b minus 35 over 3b minus 4. Now you can leave your answer as that, or you can change it to 9b minus 35 over 3b minus 12. And that's that. Let me see what Kuda would have left that as. This is number 9, right? Number 9. Kuda would have left it at this step. I don't really care which one you do. You can do the extra work there, but sometimes on tests and quizzes, you'll want to leave it unsimplified because less errors. So that's that. Let's move on to number 10. Just like in number 9, we want to start off by trying to cancel things. We want to factor everything as much as we can and then cancel. This one, though, we're not able to factor anything, right? Not able to factor anything. So we need to go ahead and get common denominators. The right one has 5x plus 3, so I need to put that on the left. So I'll have 5x plus, or you know what, let me do that in a different color. 5x plus 3 over 5x plus 3, and this is multiplying by the fraction 5/3, and then I have minus 2x plus 3 over 5x plus 3. But the right fraction, right, we look at here, this is going to be 3 times that. So the right fraction we need to multiply by 3. So here I'll multiply by 3 over 3. All right. Multiplying it together, I will have the left fraction will be 5, and then 5x plus 3 over 3 times 5x plus 3. Then we have minus, this will be 2, let me rewrite that. You'll have 3, 2x plus 3 over 3, 5x plus 3, right? Our denominators are now the exact same thing, so we can subtract here. Now, one thing to notice, this subtraction sign, it needs to go to everything here, right? In this scenario, we have that 3, so if we just make that 3 negative, it'll work out. But if we did not have this, we would have to distribute that negative to the 2x and to the 3, right? Don't forget to do that. So here, let me rewrite this. We'll have 5, and then this will be 5x plus 3 minus 3, 2x plus 3. And our denominator is 3, 5x plus 3. There we are. The top can simplify a lot, so we'll do that. This will be 25x plus 15 minus 6x minus 9 over, and I'm going to go ahead and distribute the bottom. We'll have 15x plus 9. The numerator can combine. We'll have, what is that, 19x plus 6 over 15x plus 9. All right, and let me circle that. There we are. Number 11. Same deal. We're not able to cancel anything. There's nothing here that will cancel. So we're going to be able to go straight to multiplying by things on the left and right to get common denominators. One kind of trick, something to notice, this denominator and this denominator have nothing in common, right? They are factored as much as they can. Well, I guess the 6 could factor into 2 times 3, but that doesn't help us. If they have no common factors, you're just going to multiply each other by each other, each of them by the other one. And that's what we did in this one here. But sometimes it's good to notice that. So the left one's going to get multiplied by a 6, so we'll have 6 over 6 times 6 over x plus 2. And the right one is going to be 5/6 times, this will be x plus 2 over x plus 2. Right, you see how I just multiplied the left fraction by the right fraction's denominator and the right fraction by the left fraction's denominator, right? And that will always work, but sometimes it will make it more complicated than it needs to be. And maybe there'll be a problem like that that'll show us that. So the left side will have 36 over 6 times x plus 2 minus, I'm going to go ahead and multiply this out. This will be 5x minus 10, right? Notice that I'm distributing that negative. It goes with the 5, and then it goes to the x and the 2. Sorry about that. Just like that. And let me write down an intermediate step in there so that makes more sense. We'd have 36 over 6 x plus 2 minus 5x plus 10 over 6x plus 2, right? That was the intermediate step, and that negative goes to both of those guys. Now we can combine like terms and simplify that denominator, and we will have, that'll be negative 5x plus 26 over 6x plus 12. And there we are. I'm going to have to erase this one. All right, number 12. Starting off, just like in all of them, I've said something about we need to try to factor and we need to try to cancel things. This one's we're actually going to be able to cancel these 2's. So now we have 1 over x minus 4 over 3x plus 6. Now we could factor the 3x plus 6 to be 3x plus 2, but that doesn't really help us because neither of these are written in the left fraction there. So now that we've canceled everything that we can, we're going to multiply the left one by the right one's denominator. And the right one by the left one's denominator, like that. Normally it's good to write parentheses. So the left side becomes 3x plus 6 over, I'm going to multiply this out and it'll be 3x squared plus 6x. This will be minus 4x over 3x squared plus 6x. And you can probably notice that after you get used to these, you won't want to write this denominator twice. You'll just kind of want to extend that fraction bar. But in the beginning, it's good to write them twice. So then we combine like terms, or we can make them under one fraction. We have 3x plus 6 minus 4x over 3x squared plus 6x. And combining like terms, I get negative x plus 6 over 3x squared plus 6x. And there we are. Now, with this answer, some people would, and I even looked at this and I said, well, this 3 and this 6 can cancel with that 6. But we can't do that because we'd also have to have a 3 near that x. So make sure you don't cancel when you can't, right? I think on the poster on the wall, what is that? That's killing a cat. I don't know if you guys remember the poster on the wall. So that's number 12. Let's look at number 13. All right, this changes a bit and it gets a little bit more complicated. We've got like double fractions in here, or complex fractions. Now remember that saying something like, I don't know, 5 divided by 2, that's the same thing as writing 5 halves, right? That's something we know, and that's something that we're going to end up using here. We're going to go backwards. We're going to say something like, well, here's a fraction bar. Let's rewrite that as division. So rewriting that, I would have 3 over x squared minus x plus x squared over x minus 1. Now, the division bar goes over all of them, so I need to add parentheses, right, to signify that it goes to both of them. And then I use my division sign, and then I have x minus 1 over 3x. Now, remember that we could either go two ways, and the way that I'm going to go is I'm going to change this division, because we don't do division like that. What we'll do is we'll flip it and we'll multiply, like what we did in numbers on this page, on page number 2 with numbers 5 through 8. Right? Remember, like on number 7 here, we took this division sign and we flipped that fraction. That's what we're going to do here. So this could turn into, what will this turn into? This will turn into 3 over x squared minus x plus x squared over x minus 1 times 3x over x minus 1. Now, whenever we get to this point, we could, if we really wanted to, distribute in this to these. Like, it's kind of like backwards distributing, right? But what I'm going to do is I'm going to take care of the parentheses first. I'm going to combine them first. So I'll need to get common denominators, and before I do that, I'm going to factor this left piece to see what I need to multiply by. So this will be 3 over x minus 1 plus x squared over x minus 1. From here, we can see that we have the x minus 1 in common, but we have an extra x on the left side. So the right one is going to need an extra x, and I could just kind of slyly write that in here. I'll put another x right there, and I'll put an x right there. So now, whenever I combine like terms, I'll have x minus 1 on bottom. And whenever I put the numerators together, I'll have a 3 plus x cubed, right? This piece here turns into an x cubed. And this is going to multiply by 3x over x minus 1. Now, let's write these as a single fraction. Since it's just multiplying, we can get rid of the multiplication symbol and say, well, we have 3 plus x cubed times 3x over x minus 1, x minus 1. All right. Now we can cancel something. We can cancel this x here with that x. So now our numerator becomes, what does our numerator become? It will be, I'm going to write the 3 in the front, so 3 plus x cubed over x minus 1, x minus 1. Let me double check that I've done this right so far. Yup, looks good. All right. We could leave it like this. This would be a good answer. If I was doing the homework or if I was working a quiz for my class, this is probably what I would leave it as. We could also leave it as 3 plus x cubed over x minus 1 squared. That might be a better answer because that kind of combines that denominator together. You could distribute that 3, or you could distribute the denominator, but I'm not going to. I'm just going to leave it like that. Now, if you look at the answer sheet at the end of CUDA, at the end of your packet on the homework, what they will do is they will distribute it out. You can do that always. You don't have to. I don't really care. But there's your answer. Let's look at number 14 here. Same process. We're going to change this division symbol into a division symbol. So this will be 3 over x squared plus 1 over 3, and then it's divided by 5. This will be 3 over x squared plus 1 over 3 times 1/5. And I'm going to go ahead and distribute in that 1/5 because it's very easy to do. So this will be 3 over 5x squared plus 1 over, and I'm going to leave this as 5 times 3. I'm going to leave it kind of separate like that. Now, to get what is this called? Common denominators, the right side needs an x squared, and the left side needs a 3. Our denominators are our fractions now turn into 9 over, this would be 5 times 3x squared plus x squared over 5 times 3x squared. Now we can change this into 9 plus x squared over, and I'm going to turn that into a 15x squared, just like that. And there we are. That one's a lot easier. Number 15. Same process here, only it's going to be a little bit different. Our parentheses are going to be a different spot. So we'll have x over 3 divided by 5/9 minus 1/5. Now we could do 5/9 minus 1/5 by hand, but we have technology, so I'm going to use that. What is this? 5/9 minus 1/5. I'm typing in my calculator, and I got 16 over 45. Awesome. Now I'm going to flip my fraction, and I'll have x over 3 times 45 over 16. I think 45 and 3 will cancel. What is it? It's 15 times 3 is 45, right? So this will go away, and this will turn into a 15. So 15x over 16. That's that. Moving on to number 16. Again, it's a little bit different. It's like the division sign will have the parentheses. So this will be a squared divided by 4 over 25 plus 25 over a squared. I need to get common denominators in the end. How do we do that? I guess the left side needs an a squared in both spots, and the right side needs a 25. And I'm going to write a 25 there, and then I'm going to put a little squared symbol there. Now I can put these together, and I'll have, well, a squared divided by 4a squared plus 25 squared over 25a squared. Now I can flip my fractions, and I'll have, well, a squared times 25a squared over 4a squared plus 25 squared. And then simplifying, I will have 25a to the 4th over 4a squared plus 25 squared. And there we are. You can leave it like that, or you can change the, I think 25 squared is something like 625. I'm not even going to write that down because I'm not sure about that. But this would be an appropriate, a good answer. All right, that's that. I'm going to take a break, and then we'll come back and look at number 17.